We got a meal on the soundboard. Love it. Okay. Glad to be here, everybody. I'm Ben Howes. That was the Ben that Jonathan mentioned a couple times in his presentation. Okay, let's just get through the quick little intro. So, I've been at Thornton Tomasetti for 6 years. I was, I think, the third or second hire after Nick in what became the core studio. I think, like, you showed this slide. You're going to see some repeat slides today. Like, you might see this slide 3 times. We're a global engineering consulting company, offices all over the world, practicing in 54 different countries. Another big repeat slide. So we're 16 people in the core studio now, and Jonathan and Max spun out Construe. There's another layer that we're not showing here, which is the core reps. A lot of these folks are here. So I think, like, most of the work I'm going to talk about today is application development specific, but I just want to acknowledge and thank everybody in this slide and that next layer out, the core reps. What I'm going to try and talk about today is how we make progress in terms of how we develop applications over long timescales, and we absolutely couldn't do that without sort of feedback from users, and those core reps really bridge the gap. Little mission. So, okay. So I think Jonathan really set me up nicely. We didn't coordinate at all ahead of time. We don't sit next to each other anymore, and somehow that means we didn't even talk about coordinating these decks. But I think it's going to work out really well, actually. He gave a good sort of natural history of the group. And again, I'm going to try and tease out a couple ideas about making long-term progress in a group like ours. And the name of the talk is Vectors and Trajectories. The idea being that, like, vectors map to projects, individual short-term projects with specific goals. And trajectories are more like long-term goals that you pursue over the course of years. So, like, again, the vector maps to a user experience, the trajectory maps to an API. And the way that you pursue these projects, I think, is fundamentally different. Like, I don't know, I loved the timeline, Jonathan. I think if back in 2012 or 13, if we tried to imagine where we're gonna be in 2017, we would have missed, probably not like entirely, but it's hard to predict what's gonna kind of happen, right? So I think the vector, at least the way I've been thinking about it lately, becomes this mechanism for exploring the adjacent possible. I also love the HBR slide. Besides that, the core adjacent transformational, the other resource that came out right around then was Stephen Johnson's book, Where Good Ideas Come From. And that also became sort of a sort of guidebook in a way of how to do corporate research and innovation. So the vector is almost a way of sort of navigating the adjacent possible as you sort of explore these trajectories. That's the thesis here. So this is a quick, it's not comprehensive, but trying to talk about the big trajectories that our application development group has been going after. Jonathan talked about interoperability and automation quite a bit in his presentation. We saw the beginnings of the visualization trajectory with, like, VA3C you mentioned, which was great. And I'm going to be talking about these bottom two today, the visualization trajectory and the structures AI. So if you've been following our work over the years, you might recognize some names in there. Okay, so the first one, visualization. This is really what started with VA3C, right? Again, good setup there. We built that viewer and some rudimentary exporters overnight, and over the course of, like, the next year and a half, we started to apply that technology to projects inside of Thornton Tomasetti. We've kind of talked about that in previous years, how the the VA3C viewer kind of became Spectacles, Spectacles fed Design Explorer, and those two things sort of were able to capture quite a lot of custom functionality inside of TT and support projects. We also sort of we did a private sort of branch of Spectacles that we've been developing for the past 2 years or so. And that's the sort of underlying API that's going to be realized or explored with these different vectors that we're going to talk about here. Okay, so for all these little vectors, I'm going to do just like a quick little intro and then show a video. So for the construe viewer, not construe entirely, just the viewer. The big goal was huge model support. This was like a major issue with Spectacles, the open source version. Like every model TT does would crash the viewer. You'd export a model from Revit and try and open it in the browser and it would crash. So like trying to deal with like fundamental memory management issues and dealing with huge models, that's kind of all we do. So that was a tough little learning experience, but it just forced us to sort of bite the bullet and develop some streaming technology, and happened relatively quickly. So this, again, we kind of just saw this, but the idea here is that I'm trying to show like what's different or what's specific in each little vector and how over time those vectors start to describe these larger trajectories. So with construe, again, it was huge model streaming, being able to handle kind of arbitrarily large models, and doing difference visualization, which I think Jonathan showed very clearly. This next project is kind of I would say kind of a vanilla sharing application where you can share a 3D model with somebody on the web. You can export from, right now we have Grasshopper, Revit, and SAP. Just came out recently, all the CSI tools. So again, the streaming viewer, we want to be able to do really big models, but also do sort of generic 3D data visualization. This was always like the first step with all the viewer work was just to get the models out there, to be able to share a 3D model easily on the web for free. And after we kind of ticked that off, one of the next big bits, and we kind of learned from construe, is that this 3D data visualization is actually super, super valuable, right? We all put so much time and effort into these BIM models, and it's still sort of hard to look at them and kind of see all this latent data in a lot of cases. So this is a big project. We're visualizing work sets here and just showing some of the kind of functionality of the viewer. But the idea is that any data that you can embed in an element can now be visualized in 3D. This is the kind of stuff that like we do in Grasshopper all the time. I mean, it was kind of like bread and butter Grasshopper work for a really long time, and tried to bring that functionality out to the web and let people kind of play. Okay, FIM. The FIM portal supports our forensics and PLC practices. The parking garage collapse was a good warm-up for this. I'm glad you showed it. So those groups deal with projects where something's gone wrong and they have to kind of figure it out and document it, often to support litigation or insurance claims. So the FIM data visualization and navigation, like basically being able to pour through these huge data sets with thousands of PDFs and photographs and be able to visualize that information in 3D and do searches and queries on it. So again, it's the same, like we're gonna see some stuff that's kind of a lot, or very similar. Streaming model, 3D data visualization. The interesting part here is that it's tied to a database with all this project information that links out to images and PDFs, and we're able to cobble those sort of disparate resources together. I mean, in a way, this is how we got going on the whole FIM thing. We knew that forensics needed these links between these data models they make and the actual 3D geometry. So there we just saw like a picture of a crack right? If you're doing a huge building like this and you have to show the owner or client like what's changed over the years and be able to drill down into PDFs and cut sheets and photos, we found it's much more pleasant to do that in 3D than it is like using an Access database. Or we did a bunch of like cobbled together web UIs to present this stuff to clients, but this again starts to become a little bit more robust and general purpose. Okay, so another overlap one. This is connectivity analysis and repair outside of Construe. This is an idea we've been toying with for years, like since certainly before, like back in the TTX days before Construe. We had a Grasshopper suite to deal with this for a long time, and this is another one where we've sort of been developing an API in the background for a long time, and now it's starting to be exposed, like in Construe. Application that like launches from Revit, or I think the CSI tools work, and like fully sort of immersive analysis and repair functionality. So I don't know, like this might drive some people crazy that we're like trying different things in different places, and we've had kind of heated discussions about like where should it go and what should go first. But I think one of the points I'm trying to make in the talk is that it's really productive to explore these different projects individually and to kind of finish the thought. Because without doing that, it's really tough to evaluate the work and to kind of take the next productive step. So yeah, we're seeing kind of a repair operation here on, this is a chunk of one of our big projects out west. You probably all know this project. We're still not officially supposed to say what it is. Okay, so let's finish it. There's a cute little ending here that Leland laced up for us. And I'm doing okay on time, so I don't have to rush. I don't have a cute cat stretching video for your wall. That was terrific. All right, so that was the first trajectory, again, the visualization platform. This next one, all the names are still sort of in flux, but the kind of long-term idea is an AI for structures. And this is another set of ideas that we've been teasing out for quite a long time. I'm going to show some old work. Some of you might remember a project called Remote Solving. We presented something called Green Space a couple years ago or a year ago. So this idea has been in the works for quite a while, and again, we're now sort of over the past year and a half, 2 years, developing APIs to really go after that long-term goal, and we're doing so by sort of working through these short-term projects. So 4 of these as well. The first one's called Skipper, and it's about bay design, typical structural bays. Rob has a great ROI slide. I didn't include it here, but on even a building like this, he shows Tower A, enormous projects with thousands of individual structural bays defined by girders and infill beams. People end up designing the same thing over and over and over and over again. Every engineer does the same kind of hand calc for strength, and they use RAM or some other piece of software to look at vibration, and it takes time. So we wanted to, and frankly, it's a little less than pleasant from the user experience point of view. So as we start to approach this idea of like web services or web applications to start to automate structural design, we also want to provide modern user experiences and response speeds, do things quickly and pleasantly. So this is our first attempt at, in a really focused way, trying to just automate one bit of the design process, bay design. So this little user interface calls into our backend APIs to do all the analysis and design, and allows users the ability to sort of quickly interact with a lot of different options and look at performance metrics. So instead of a 10-minute feedback loop, it's like a second at most, milliseconds, right? So again, kind of like modern performance, people who are used to working with the web. And this is, I think we're in beta on this one. Like this one's actually starting to be used productively out in the company. And it's interesting to see people's reactions. Some people, like, the first reaction, well, that can't be right. Like people are kind of still vetting it and getting used to something that works so quickly. Okay, so that's the first one. This next one is called Sphinx. Again, this is like a second or third generation of some work we did or started doing back in the ACM days that we called generative structural design. Basically being able to do parametric structures in a platform like Grasshopper or Dynamo. So we're in Rhino and Grasshopper, and we're going to see some sort of, again, like this is a single typical bay calling into the same backend API. So the stuff we learned in Skipper about, well, and even the kind of interfaces for what users want to be able to change, we can expose that stuff in a different environment and allow users, Grasshopper users, to sort of, again, do this like really, really quick, intuitive, short feedback loop design process. That was a design where beams were being sized. We also have verification and kind of automated code checks. So this is more like visualizing something that's already been sized and an analysis has been run. I think we're going to see a utilization heat map here. So just showing that, you know, we kind of have both capabilities, both design and kind of verification. The next one is in Revit. Again, all the names are sort of in flux, but the goal was outlier identification. As Jonathan mentioned, a lot of these projects are designed in various softwares and kind of everything gets funneled into Revit, be it Construe or in less ideal cases in other ways. But everything sort of ends up in Revit, and there's always this process of sort of just marching through the model and trying to find beams that are missing shear values or are not tagged. It's a manual process. So can we use some of these automated tools that we're developing to start to run these kind of quality assurance checks and ultimately, hopefully start to do structural design right in Revit instead of having to kind of bounce all over the place. But this one's just trying to show some kind of outliers. You can probably get a sense just like looking at the complexity of the buildings, like this is the stereotypical little twister of how mature these tools are. This stuff's still pretty early relative to some of the visualization work where we're showing, you know, really big projects. But again, it's about working through some of these ideas, finishing the thought, and letting these small vectors inform the way the trajectory should go. Okay, last project. So this one, again, I think the idea here, and like I think everything except Construe that I showed has been internal, meaning it's been built for TT. This next project is one where we're considering kind of pointing this outwards again. Don't quite know how or what the model is, but the idea is to provide rapid conceptual design feedback to architects at a very early stage. And again, by rapid, I mean like immediate, very short feedback loops. So just a little context on this one, because again, we've kind of been toying with this idea for years now. We have remote solving up in this corner. This was some carbon embodied energy research we did a few years back. Some of Dan's machine learning research, and Rob and Matt put this green space project together. So I think all of these projects sort of start to get at this idea of, in one way or another, doing engineering as a web service. So can we, instead of kind of providing answers at a human pace, like hours, days, can we expose some of these kind of encapsulated engineering models as web services? So that's what this last little prototype, this is, we mocked this up with human UI, and it's basically running in Grasshopper right now, but the plan is to sort of migrate this into a full web application similar to some of the earlier work. But there would be sort of user inputs, geometry, structure, like program types that define loading criteria, base spacing, et cetera. And as you make these changes, you get some sort of quick feedback about cost of the structure, tonnage, embodied energy, these kind of high-level metrics that can start to be used to drive the design process. So we're still working out quite a number of things and trying to get the sort of performance and the quality of the answers to a point where we're comfortable sort of, again, exposing this stuff. But that's the plan, to sort of face this back out into the market and let people start to interact with this as a early design feedback tool. So my old buddy Matt Noggle put this slide together for a different presentation, but I think it kind of sums up the idea well. If we do end up sort of having that client-facing or outward-facing bit, it's going to be kind of the tip of the iceberg. And over time, we're going to develop more and more and more of this functionality, capability, kind of teaching the AI new tricks, as it were, populating it with real projects, and really starting to let some of the machine learning stuff take over, and hopefully provide or be able to sort of teach not just you all about what are good design decisions for your massing models, but also internally at TT to help people deliver projects better. Thank you very much.